I've been working on metadata technology for 7 years now at Adobe, and we are doing the engineering of the libraries and support and integrate them in all arbitrary products. And we also do customer support and the support of our own application, obviously. I'm also a member of the working group in the ISO 130, which is responsible for the standardization of first the XMP core standard and the next relaxng validation standard. So today I want to make you familiar with a new possibility to validate XMP using relaxng. And let me show you the agenda first. Let me start to explain these two standards. The first standard you are already aware of. Yesterday we had a very detailed and very good talk about XMP metadata and its problems from both of you. That was very good, and so I can fairly assume that you are familiar with XMP, and I don't need to go into detail very much anymore, and I can build on that. So in the first part, the first standard contains the data model of XMP, how metadata is stored in general. Very important is the serialization model, which is RDF XML. This is used to embed it in files, as we've heard yesterday. And it also contains a set of core schemas or core properties, which are very often and commonly used. And as you can see, it does not contain anything about validation or machine-readable schemas. So that's what the second part of this standard is going to address. I have to warn you that it's kind of a future and upcoming standard. There are not a lot of tools at the moment, other than the standard open source tools that can be used. But as always, it takes some time until the standard is voted on and going through and finalized. There's a vague plan to do a third part of the XMP standard, which would address UI and all UI experiences. Very nice. The goal is that that the user has consistent experience in all kinds of applications when editing or consuming metadata, but that's only planned for. It's not really happening at the moment. So next I want to talk about what is XMP validation, why it's important, why it has been decided to use relaxng and not other, maybe more common validation languages. Then I want to give you a short introduction into relaxng because it's really the basics of it all, and it's I assume that really hardly anybody knows about that. If so, I apologize if I am boring you with that. And most of the time I would like to spend to walk through the standard and explain it actually to you. It's very technical, but I try to do it in a tutorial style, so it should be fairly easy to follow. And if we have time, I would like to talk a little bit how we can write validation software. Okay, so next. We've already seen that yesterday. If you look at a raw piece of XMP, you can see that the properties, there's, for example, Dublin Core format. The prefix, it's just a piece of XML, and you don't know anything what kind of property that is, actually. The Dublin Core refers to the namespace, the prefix DC. The format is just the name, and the value of the property is just an arbitrary string. You can only guess that the first one should be a MIME type and the second one should be a number. And the third property, which is completely unknown, I don't know what it is. And at the moment, XMP schemas are only defined in prosa or prose. So here's a short excerpt of the XMP specification. So you can see it's written that the DC format is a MIME type, and it's also explained what it's all about. It's a file format, a physical medium, or dimension of the resource. It's just explained human readable. And there are some missing pieces in that. For one thing, how can we validate against that? It's not possible. I think yesterday there was a nice slide about the in Francois' talk about the human who is reading the PDF specification and several times, and then he's implementing the validator. So at the moment, all schema knowledge, it's all in the code. So all UI that we have in the Adobe application, it's just knowing what it's expecting in the XMP. It's just reading the MIME type and knows, oh, this must be MIME type, so I display it as a string, and so on. Or this is a rating, I should display a star rating, or somehow. And so what we need is a machine-readable schemas, so that we can create new custom schemas. And the second thing what we need is a validator, which can just say if the XMP is fine or not. In the context of PDFs, this would just be a small part, making sure that the metadata part of the PDF is correct. Okay, so first I would like to talk a little bit about what is XMP validation and what are the requirements for that. So I've figured out that there are several levels of validation. So if you look at the raw XMP data in the file, first of all, it needs to be a well-formed XML, actually. If there is a missing tag or a missing parenthesis, or some brackets missing, then the XML parser cannot parse it. And that would be the very most obvious error. And this is already addressed, I think, because you cannot parse it otherwise. And once the XML is fine, the next thing would be to make sure that it's valid RDF format. So valid RDF XML is the serialization format of the resource description language, resource description format. And, well, that must be well-formed also. And then the third point is that XMP is only actually a subset of RDF. For example, just as a small example, in RDF, arrays can be done by repeating properties. For example, say DC title and another DC title. While in XMP, we have to clearly define an array for that. Otherwise, it's not valid. And if that's what I call the syntactic validation part, and I think this is already addressed. So our XMP toolkit and parser is looking after that, and you can see proper error messages for that if there is something wrong. But more important is the semantic validation. And to start with, if you find some properties you want to know, is it a known namespace where we have a schema for, which is defined, or is it an unknown namespace? And when we have a known namespace, then we must make sure that all property that appears in the XMP is defined in that schema. If sometimes people tend to add properties to existing namespaces because they don't know better. And if there are custom namespace, we need a schema for that somewhere. Otherwise, we cannot say what types the properties are of. And well, that's the third part. That would be the values. If we have values, they can be numbers or booleans or regular expression like the MIME type. And this should be checked as well. And on top of these basic validation, you can think of like additional validation. For example, you want to have a title which is always prefixed with PDF association, for example, just a custom validation. Or you want to have an array with a specific with at least 3 items, but at most 10 items. Or you can think of all kind of user constraints, or very practical maybe, I want to check if the copyright is in the metadata before I export it. Or I want to check that some internal data is not in the metadata before I publish something. So these are all kinds of things that we would like to address with this validation standard. Okay, so next I would like to talk about why we selected relaxng. We looked at different validation languages. For RDF and XMP, there are no very well standard languages, so we decided to use an XML validation language. So relaxng is short for regular language for XML in the next generation. So that's the second try. It has evolved over some years out of the DTD language, but it's more generalized, it's more mature, and it's really actually better than DTDs and even better than XML schema and easier to understand. By the way, you can convert each DTD into a relaxng automatically if that would be necessary, and you can convert each PDFA extension schema in theory into a relaxng. Okay, so the pro for relaxng is it's also a standard, and we heard yesterday that's very important that each part in the PDF is relying on standards. Otherwise, the underlying specifications can change, and then you have a problem like it happened with the old XMP specification and the PDFA standard, which has changed underneath. So relaxng is easy to use and good readable, and very important that it has support for unordered content. I will explain that later. So in XMP the properties can be mixed, and this would be very hard to explain in other schema languages, and in relaxng this is out of the box. It supports namespaces, and a very nice thing is that you can add custom annotations. That means you can add, like for example, you can, if you like to add labels and descriptions for your UI into the schema, you can do that. You just need to if you pick another namespace, you can decorate the relaxng file as you like, and it's still valid and it's still working in default validation processors. I may show an example later. Okay, the contra is that we use an XML validator, not an XMP validator. And as we've heard yesterday, XMP has different theorization forms, and that makes it a little bit more complicated. And this is addressed in that we propose in the standard that XMP is serialized in a canonical form. So in a very specific way, so that we can validate this specific form of XMP, which makes it much easier. And well, that's it. So let me give you a short introduction into relaxng, what it's all about. So here we have a very simple XML, an address book with cards. It has nothing to do with XMP for a moment, for the next minutes. And there is a name and an email address in the card. And now I want to validate this. How would I do this in in DTD? This is an old DTD, and now I show you the relaxng. So as you can see, it's quite easy. It's basically that each element and each attribute in the XML has a corresponding validator in relaxng. So in relaxng, basically it contains of elements and attributes. And in the attributes and in the elements, there's just a text tag. That means it can contain arbitrary text. So that's a very kind of simple XML, and the validation is not much longer than the XML itself. The 0 or more tag just means actually that you can leave it empty, the address book, or you can have one or more. You can have 0 or more addresses in your address book. And why I'm going through that is now I would like to show you how can we structure this file. Let us assume that's a very long validation file. I want to show you how relaxng supports structuralization. That's my word, which I cannot pronounce. Okay. So, okay. Now, relaxng supports named patterns. That means you can take parts of relaxng and just put it into a pattern and define it like a method in a program. You can refactor it into a pattern and then reference to the pattern. And you can also use include files. And I'm telling you all this because we are using this and this very heavily to structure the huge. There are huge validation files for XMP in the end, so we need to structure them. So now I want to refactor the card pattern. So as you can see, I have a definition on the right where I've just defined card type and put all the same validation code into this and in the pattern, and that's basically all. And now what I need to do, this works over there, and now I can replace in the main relaxng, I can just replace it by reference, and that makes the main validation code much shorter. So what's next? Now I need to have both paths, the definitions and the main XML. How can I put it into one file? Now I have two parts, and that therefore I need some boilerplate. So the final relaxng on the left is now a relaxng file which contains of several definitions, needs an outer grammar tag, and it needs a start tag so that it knows where to start with the validation. Otherwise, it would not know where to begin. And within the start, I can use the references. And here I use the reference to the card type, which is actually copied below that. And then I have a complete refactored relaxng file. So what I want to do next is to split it up into several files. That's very easy as well. I just create a new file with my named patterns. It gets an outer grammar tag. That's each relaxng file has to have that. And then I can just include it like in XML. And I can use multiple includes, and I can add multiple defines in one included file. Oops, that's pretty straightforward. And that's basically it for the short introduction to relaxng. You don't need to understand it into detail right now, probably. Now I would like to walk through the EaseDraft. That's the document. This is a table of contents, and the major parts are, it's an introduction, and it contains all the usual references and terms, conditions. The conformance explanation means that conformant validation software should do it like explained in the standard, so that the schemas that will be created, or that we propose how schemas are created, these schemas should be interchangeable between different validation programs later on. Otherwise, it would make no sense. And that's the conformance explanation. Afterwards, the canonical theorization is explained. This is basically the preparation of the raw XMP so that it can be validated against these idioms that are proposed in the standard. Afterwards, well, it is explained how XMP properties should be expressed in relaxng, simple properties, structs and arrays, and also qualifiers. And the Annex is maybe the most important part. This one actually contains all the example validation files for all the schemas that are included in the first part of the standard. And they are ready to use. You can just take them, and they will be also shared as files so that they can be used right away. And so with a little bit copy and paste, you can also create your custom schemas quite easily, probably. So, okay. So the canonical theorization, I've said most of it already, because XMP is ambiguous and because it has some complexity when it comes to qualifiers, and so we choose just one well-defined kind of theorization, and this is a prerequisite to run a relaxng validator with the proposed relaxng schemas. I show an example. So this is a structure, an XMP structure. It's a structure derived from, it contains two fields, document ID and instance ID. And this would be, I just show you the three kinds of theorization that we have. So just, this is the ambiguity, just that you can see it. So for example, this is the short form. There you can, the fields of the struct are as arrays in the XML, as attributes in the XML. And so the next one is I called it classic because that's what Adobe used most of the time. There we have the structure fields are child properties, and the struct itself has a resource qualifier that tells the parser that it has child properties, actually. And the third one, most importantly, this is that we choose to be canonical. It uses an inner description tag. We've seen that yesterday, I think in your example as well, to tell the parser that derived from the struct and that it contains children. And we use this form because it is pretty straightforward. As you can see, the outer, in the XMP package, the outer tag is also an RDF description tag. That means that a structure is actually a kind of mini schema one mini schema for one property, and it looks similar than the outer XMP packet. Okay, so let's see. Now I would show you how the annexes are structured and explain you how the annex files are working. So we have example files for basically all core property files from the first part. This is Dublin Core, the XMP namespace, XMP multimedia namespace, and the XMP rights. And they make heavy use of this structurization. Dietrich, please. And so these are the files. Because I have to explain the structure. The main goal was to have an individual file for each schema so that I can select which schemas I want to validate against. But because in a normal validator, you can only validate one XML against one validation file. That means we need a kind of aggregation document which includes all the other single schemas to make it a single relaxng file. This is only used to run the actual validation with a standard relaxng validator. Then we have individual files for each schema, which contains a list of properties. And then we have type files. We have one file for simple types, one for array types, and one for type structures. Because XMP properties nearly always have the same, they share the same kind of types like text, integer, array of integer, and so on. And so they are refactored out and they are sharing these types. And so if you do a custom schema, for example, then you should make use of these include files so that you do not have to retype all the existing types once again. Well, actually, if there should be software in the end to create new schemas, it's still a hard thing to do, to create a schema manually, but that's not the goal finally. So I will show you an example and walk through these. I show you the complete packet, and I show you an example from Dublin Core, so how one property is defined through. It's too much to go through all these files, so I just take a simple property as an example, how this looks in these Annex files. So involved are these three files, the mothership file, as I called it, which aggregates all the schemas. Then I show you one schema file, and I show you one of these three type files. So this is the aggregator, the complete packet. It actually defines the outer RDF and the outer description tag of the XMP packet. And then it includes all schema files via reference. So they appear two times, the include file and the reference of the named pattern. And very important is this interleave tag. This is a relaxng feature. That means that each property of all schemas can appear in an arbitrary order in the XMP packet. It doesn't matter. They don't need to be sorted by schemas or alphabetically or whatever to be validated. That's a very strong feature of relaxng. So the next file, this is actually an excerpt of the Dublin Core property file. And important is that the namespace is defined up there and bound to the prefix Dublin Core. Then what we do, we include all these type files in case we need them. And then there's a list of properties, which I show on the next slide. Now the properties come. And each property is appearing to having a better overview. It's verbose, but it's very it gets you a good overview. It's appearing two times in a file. First, it starts out with a simple list of references of all properties that are in the Dublin Core namespace, which are actually 15, I think. And then we have a named pattern, a definition for DC format, and in that I defined the relaxng element, which is, in this case, DC format. This is actually the XML tag which would appear in the XMP. And this makes use of a standard simple type. You can actually put the validation code for each property right inside this file if you have a specific new property. It's kind of, you don't need to structure it like this. This is just the proposed way of structuring it. And so it references to the MIME type. The long reference name is, has been chosen to make it unique. So it's the standard name, it's a type, and it's actually a Q value, which is a tag, and the type is a MIME type. And where these names are just like variables, you can name that you can give them any name if you like. So what's now? So the upper refers to the lower one. Then there's the property name. I forgot to click these through. Then there's the type reference. And one nice feature as well is that each property in an XMP schema is optional. That means the XMP is still valid if you leave away some of the Dublin Core properties. But you can change the schema or a custom schema that you make it mandatory. If you skip the optional tag, it's mandatory that the XMP has to contain a format. Maybe you can do that with copyright. It becomes mandatory to contain a copyright. Okay, last for that is actually here we see the type file or an excerpt, and here you can see how the MIME type is defined. And I chose that example because it's actually just a regular expression, as probably everybody know. And it's the data type for the simple type is a string. And on the string is a pattern, a constraint of type pattern. There are several other ones. For example, for integer we have min and max and all these kind of parameters to the types. And in this case, it's a simple regular expression. And this would come in handy if you write a validator. Then you can just pick this regular expression and use it in the validation. So it's already in the schema, which is very nice. Okay, and so this was kind of my, let's see. Next is, this is basically the annexes, how they look like. Now I have some time left, then I would like to talk about a minimal validation application in Java. Are there questions until now? Does it make sense to?
Yeah, just in your example, beforehand with this MIME type and the main entry before the slash. So as we mentioned yesterday, what would happen? I don't know if there would be a new main MIME type being invented. Does that mean that the ISO standard would have to be? That there needs to be a new version of the ISO.
No, let me go back. Well, in this example, actually the MIME type definition is as such that the first part of the MIME type is, I think, already standardized. There's the main part, and the latter part, it's just an arbitrary kind of strings with separated.
I mean the first part, so maybe there is, I don't know, some kind in the future, maybe 3D or I don't know.
Then you would have to change that actually.
And then you need a new version of the XMP ISO standard.
Then it would have to be updated. You could argue that it would be enough to just make it a general regular expression for arbitrary MIME types. We could think about that. That's still in the works, kind of. So it would be a good discussion if we should do that way. But
so is the validation pattern as well part of the standard?
Yeah, actually, yes, it would be. It's the Annex, actually. The Annex is not part of the real standard, which makes it actually easier to change it. Okay. The Annex is not a normative part.
Yeah, you can run.
It's just an example, actually.
Okay. And that's fine if you just put a regular expression in there, in the first part as well. It actually takes away from the validation possibilities. Because you don't know what to expect in the first part of the MIME type.
Yeah, as far as I know, the MIME type is specified, so the first part does not change anytime soon, other than the countries, which are probably changing very often. Okay, so now the minimal validation application, so this was kind of my prototype and kind of mini reference implementation just to check the schemas that we put in the annexes. We have to make sure that they are really actually working. And the idea is I picked an open source validation library, and I took the open source XMP core library to do the preparation, the canonical serialization. And then I included a copy of the Annex file SAR in the standard draft. And so this is really very easy, because you feed the complete packet, which is the mothership document of all standards, into the validator. It is passed into a relaxng validator in memory, and then you just, on the other side, you prepare the XMP packet to be canonical, and then you just run the standard validator. And then you get either no exceptions, which would be good, and the XMP would be okay. And if there are errors, then the validator would throw an exception. But the problem with this simple approach is obviously that the error messages are not very good. There are exceptions like, well, I did not expect this tag to be here, or here's a missing list tag, or something like that. So this kind of implementation is too simple to really use it. It can basically just say thumbs up or thumbs down. It's working fully, but the error message is not very helpful. So for tooling, we need a more robust, better implementation of these validators. But I'm still showing you how simple it is to do the first step. So here's a rough class that I did. It's very easy. You feed the relaxng file, the main relaxng file, into that, which includes all the other 7 files. And then it compiles. And then I call a validate method on my XMP packet, which comes into some kind of stream out of a file or wherever. And then it just throws an exception if something goes wrong. Or it doesn't throw any exception if everything is fine. And this validation method is using, I have this validation method here. The other stuff is not so important. It just first feeds it into a normalized XMP method, which is just kind of parsing and reserializing the XMP in a canonical form using our XMP core library, or any library that exists. I think most adapters use actually the open source libraries that Adobe publishes. And then the answer, the byte array, is repackaged into a stream, and then you just need to call the schema validator. This is a Jing validator. You can download it from the internet. It's working very well. It's very efficient. And you create a new instance of the validator, and then you run it through the validator. And that's basically all for a very simple validator. And next is the next steps with this validation standard should be, first we need to evaluate it, and the standard needs to be finished. It has been voted on in the last ISO 130 meeting in May, but now there's some feedback coming, and the feedback is worked in, and maybe it takes still more than a year until it's actually finalized. I would ask adopters of XMP to to try to use it and try if they can work with that, or write maybe validators on top of that. Maybe Adobe should do this. Actually, we are still using relaxng files in some workflows to validate XMP when it's read when it's uploaded to the Creative Cloud. There we use the schema information to convert it into JSON documents and store it in databases. We already use this relaxng as machine readable schemas, but it's not mature enough, so it's not published yet, this piece of software. Okay, then, and if it would become a standard eventually. Then I think it's time to think about how this could be working in conjunction with PDF validation. So this could be used to validate the metadata part of the PDF. But this is actually future talk at the moment, because so if PDF would change this, sometimes it would be in the next standard, and the prerequisite would be that the XMP validation is standardized first. And then one could think of what shall we do with the schemas. At the moment, the extension schemas are directly in the XMP data. And, well, relaxng cannot be embedded in XMP very easily, maybe in base 64 encoding, but that's what really be horrible. So there must be a different way to either include the validation files in the PDF, and maybe can be another approach to host them somewhere on server so that they can be retrieved via the namespace. I think that's pretty open. We should think about that, how this could be working. But, well, in practice, in software products, this kind of validation can already be used. Actually, I'm not sure if the draft is publicly available in this early stage. I hope so. I don't actually know.
I think usually these things should be available for PDF association members and
yeah.
in the internet.
And sometimes it's even in the internet. I haven't looked up, but it should be there somehow. At least I can share these the annexes, and I can share my Java application to try it out.
But this Jing validator, does it also validate custom extension schemas, or is this?
No, actually not. Jing is just a relaxng validator. It does not know about XMP. It's just using our specific idioms that we created to validate XMP and runs it against XML. So for Jing, it's just the schema is an arbitrary schema, and the XMP packet is just arbitrary XML. It does not have domain knowledge. Okay, so that's my main slides. But as I have some time, I might talk a little bit about. I go forward. I would like to show you a little bit more what you can do with relaxng. For example, earlier I introduced these custom annotations. Relaxng is capable of, you can put any additional, if this is, for example, for DC writes the schema information, then you could define an arbitrary namespace. I just invented one, and for example, you can put into the schema an info structure, like this is an additional information for a property, and this might contain a label and description for a UI. That would make a UI generation tool, would leverage UI generation tools in creating UI for a schema, which would be very nice for custom schemas. We are already experimenting with that, and it could be saying if it should be read-write or not in the UI, and we could even give the property a version. So if it would change eventually, which is hopefully not happening anymore, then there could be a version in that, and you can even add more information that are company specific, anything what your company needs to be in there for workflows. And the relaxng validator is just ignoring all this stuff. Actually, you can even add custom attributes besides in the RNG define tag or anywhere else. You can add attributes and tags anywhere as long as they are not in the relaxng namespace. So, okay, then I've a few thoughts about a robust extensible validation library, how this should be done. When you want to have really good validation, you would not take probably a default open source validator. You would like to have a more clear error reporting. And so my basic idea was that first we will make heavy use of this annotation that I showed you before. So put in the label and description and everything to have even more information in the schema. Then was you can use a relaxng parser only, not a validator, just a parser, to parse the schema files, only the schema files, not the complete files. So you can parse the individual schema files and put them in somehow in a memory representation, so that you have the validation schema in memory. And when you've done that, you can do a really easy validation programmatical. You just kind of loop through the schemas and look up if there are unknown schemas, and you can report on the errors or warnings that you find. The advantage would be the Jing library, for example, the Jing validator stops at the first error, like most validators do, like the XML parser does. It stops at the first error and then you're out. But that does not make sense if you validate a PDF. You want to have a list of, say, these 10 properties are not defined in any schema, and these 3 properties have the wrong value, and this property should be an array, but it is a simple property, and all these kinds of errors should be reported somehow. And so I would advocate to use relaxng, and it can be used directly with standard validators, but I would prefer to use it just as a file format for schema, for custom schemas. This file would be read into memory, and then it could be used to create UI. It could be used to validate. It could be used for custom constraints, and so. Ideally, I would like to see, for example, that the tools that are out there could just read a relaxng file and present UI for that to the user, and put it and validate the XMP at the same time. So if there's enough information, like these custom annotations, it would perfectly okay. For example, you can also add. Let me see, if you have a star rating, you could just say, please use a rating widget for that, so that your UI framework can pick it up and create UI. And using relaxng that way, you would really solve 2 problems that I listed initially. First, we have a machine-readable schema, and we have second, we can do validation, and we can do validation. Either we can make it ourselves, or we can use standard relaxng validators, and so that would solve a lot of problem. So in the first glance, it looks very complicated, relaxng, maybe, if you have seen it for the first time. But if you look closer into that, it's pretty structured and it's really straightforward. And hopefully there will be tools to create schemas like Color Software does today for PDFI extension schemas. There will be tools to create relaxng schemas as well. So we have listed a few, oops, didn't want to put that. I've listed a few links in the presentation here. I assume that they can all be downloaded later. Yes. So here is the release of the first ISO standard, an interesting read if you want to go to sleep. And then there's the relaxng tutorial, which is very nice to look a little bit deeper in relaxng, and the open source validation tools. There are also some for C++ actually. I use Java. And you know the Toolkit SDK, where you can get the Java version and the C++ version of XMP, the XMP libraries. Yeah, and that's basically it. So thanks for coming, and now we have maybe some minutes for questions.
Any questions?
You can do it otherwise offline later.
Do you have the possibility to have some crosswalk between 2 properties, for example, to make sure that the value of one property is the same as the value of another property?
Actually, no, not. That would be difficult. Maybe you can put it somehow if you use the same type reference, but I think this is too complicated. This cannot be expressed in the schema language. But what you can do is using custom annotations to make more complicated validation on top of the semantic validation.
Yes, okay, but that would not be covered by the
by relaxng, right?
In this case.
So it cannot compare contents, values, or so. That's not possible. Just the structure of the values and the type.
I think there are some crosswalks between properties in the XMP, or
Not a lot. What you could do is say if you have a GPS coordinate, you should have both coordinates, for example. But it's not so important, I assume, because they are either there or not.
But of course, then the validation against an embedded extension schema will also not work. So
no. Then we will have first to extract the extension schema, create a relaxng schema included in the main file, and do the validation.
Yeah.
If you would want to use this in the context of PDFA, I would assume that you would have to include the relaxng schema in the PDFA file, because you can't work with references in archival context.
yeah, but actually right now it's also the case that PDFA just says, okay, it's either predefined or you have an extension schema, but that means predefined. The term predefined already means that you have an XMP specification somewhere where you can read what is predefined. So it's not the requirement is there that PDFA needs to be self-contained, but still it references some specifications.
So you could refer to all of the standard ones.
Yeah.
As predefined.
What I have heard, you can completely do PDFA validation with regards to predefined XMP properties. That would be fine, but if you have custom properties and then you need for PDFA to embed your own extension schema, then it will not be possible to validate whether all custom properties are perfectly covered by the embedded extension schema.
But if this becomes a standard, it looks like this could actually replace what you use today with extension schemas, or is there?
Yeah, you use it.
It looks like
In
much the same thing.
PDFA4 or whatever, one could say, okay, we have a new language for defining extension schemas, maybe based on relaxng, and then you could write an application that would take the schema, the relaxng schema, out of the PDFA file and would use it in order to validate the metadata.
Yeah, and I think there are some things missing in the extension schemas.
Yeah, you cannot cover all.
And I think types cannot be, like regular expressions cannot be done there.
Yeah, but you usually can do what is required. So
Yeah.
it's just a theory. In theory, there are probably some missing. You cannot do everything what you could think of that one may need, but I've never. So usually it's just simple types or maybe structures, but nothing else.
Yeah.
Any other questions? No.
We're running out
Very
of
much.
time.
That was very clear, actually.
Thank you for coming.